So here we are. We are starting this channel kind of up again. I kind of went on hiatus. Life has been crazy. Um, but here we are again. I'm starting off with chapter 5. Um, this is problem 21 out of the textbook. This is the Hibbler Statics 14th edition. So if you have this textbook, great. If you don't, problems like this are kind of similar throughout most textbooks and everything like that. So we're gonna just dive right in. Always remember to like and subscribe. It helps build my channel. I am surprised that this channel has any views at all. So that's kind of why I was like, oh, whoa, no way. So I'm kind of diving back into it. I have a little bit more free time, a little bit more time to have some fun like this, and I kind of miss making videos. I kind of miss um, teaching, to be honest. So we're just gonna dive right into this problem. It's it seems somewhat complex just looking at it, but I'm gonna show you a way to make it real simple, real easy, and you can solve it one equation. So we're just gonna go right ahead and do it. So uniform rod AB has a mass of 40 kilograms. So basically, what that means is the weight is distributed equally. So that means the weight's gonna be like the force of the weight's gonna be in the center, right? Which is like right here, 1.5 meters, right? And that weight's gonna come down here. It's gonna be 40 kilograms, which is just that 40 times 9.81. Will give you the force, right? And then in this position, this is a smooth collar, which means it's not gonna stop it in the X in the Y format, and it's gonna produce a normal force of A. So we'll indicate that. So we have one unknown, and looking here, we have a roller. So that means we have a normal force of Bravo. And then here we have the tension. So that tension's always going to be kind of this way. So we're going to call it TBC, tension TBC. Now, looking at this, you're like, how can I make it one formula solution, right? Well, as you know, some if I'm holding my sum of forces in the x has to be 0, my sum of forces in the y have to be 0, and my sum of moment have to be 0. Now, the great thing about momentum is that you can actually choose the point, and that's how we're actually going to use it. We're going to use the sum of momentum for this problem to get it to a very simple problem. So what we're going to do is that you see, well, this is kind of heading in this direction. Dash line. And this one's headed straight up. Dash line. Boom. This is where my momentum I'm going to be. We're going to call it point P, which why not? And the reason why this is great is because this is causing no moment about P because of where it's at. And this is also causing no moment about P because of how it is. Because the way we calculate momentum is we have the force perpendicular to our line, right? Times the bar, right? So it'd be like, so if I'm looking at the weight, oh wow, I made a nice straight line, so I can barely see it. Um, I'm going to need to know this distance because this is perpendicular. And for T, for this tension, I'm going to need to know this distance because it's perpendicular. I'm going to just call it Y. Why not? Right? And the great thing about momentum, so like I said, so that means sum of momentum about P is going to equal 0, which in our case, well, we can calculate this. Well, we know this is 1.5, and we know that's in the midpoint, so we know this distance x is also going to be equal to that distance x. So realistically, what does that mean? And we also know this is 60 degrees because of basic geometry. Our basic geometry states that because this line's parallel to this line, this has to be equal, right? Going all the way back to geometry to find that. So to find x, the x is just going to be the x is going to be 1.5 meters times the sine. Ah, my bad. Why did I say sine? It's cosine, clearly. that was a huge blunder. That is the cosine of 60. And then times, and then to find that momentum, so then to find the momentum, it's really 40 times 9.81 times that 1.5 times cosine 60, right? And there. And that is my momentum based off my weight according to P. Now, nice thing about momentum is as well is that so that's gonna like cause a momentum this direction on P. Um, God, I'm trying to what is that counterclockwise? Yes. And in my case, I'm just gonna make it positive because this tension is gonna cause a clockwise rotation, which I'm gonna make negative. And the reason I'm gonna do that is that way it the momentum from TBC is gonna be minus, and to find this, right, it's really just that 3 meters times sine 60. And then it's just gonna be TBC times 3 times sine 60. And look at that. One equation, one unknown. We can go ahead, solve for the tension just like that. So I'm just gonna step through it. Um, so multiply all this together. That should give you 294.3. And I just went ahead, simplified this, and that would give you 2.6 times TBC, right? And this is equal to 0. Well, that means I will have that 294 plus 2.3 is equal to 2.6 tension BC, and then just wow, definitely tell my game. Then simply just divide that 2.6 into the 294, and that will leave me with TBC of 113.27 newtons. Or if you want to simplify it to just the newton, just the whole numbers, 113 newtons. Boom. And that is the answer. And like I said before, problems like this, you're first shown 3 unknowns, and the question only is looking for one. Well, in my opinion, the best thing is to find a way to exclude 2 of them, which in this case we can. We just made a point of P where we're gonna look at the momentum of the system. That momentum at P has to equate to 0 because we are not moving, and we're all standing, so that momentum has to be 0. And then from there, well, you can cancel out anything from any possibility of NA having any kind of play in the equation, and same thing with NB, and then you're left with just TB, the tension, and the weight of the bar. And then from there, you can solve for the tension in the rope. If you have any questions, I'm going to leave an email in the description that you can always reach me at. Or if you have any additional questions that you would like to see on this channel, just go ahead and leave a comment. I'm more than happy to look at any questions you have. Well, thank you for everyone for listening.